Let's now use the dot product to talk about orthogonal vectors. Orthogonal vectors are vectors, well, let's define this, vectors that have the same initial point and their lines are perpendicular. They form a perfect right triangle. Now, not all vectors are orthogonal. For example, these two vectors, v and w, are definitely not right triangle worthy. They don't have a right angle anywhere. So we can do what is called the orthogonal projection. This is where we're actually going to change the length of w so that it does make a right triangle with v. So notice here we can make w smaller, meaning I'm just making the magnitude smaller. I'm not changing the direction. But if I change the magnitude of w, now I've got a right triangle. The reason this is called the orthogonal projection is because we're projecting v onto w to make that right triangle. Now, this is the equation for it. And I wanted you to highlight a couple things. This little one is the one you're changing the length of. This big one, v, is the one you're projecting onto the little one. So you're going to take v, we're going to project it onto w, and we're going to change the length of w so that it makes a right triangle. And this is the equation we use to do that. We do the dot product of the two vectors divided by the magnitude of the one you're changing squared, and we're going to multiply the one we're changing by this number. Now, this is kind of a weird idea to try and wrap our minds around, so let's start by visualizing this example. I have two vectors. My first one is at 1, 1, 2, 3, 4, 5, 6, 7, 8. So there. Oh, that's not very good. Let's try that again. There we go. We'll call that. There is vector v. And then I have vector w, which is at -1, 2. There's my vector w. Now, notice if I project v onto w right now, that is not a right triangle. So if we are going to change the size of w, do you think we're going to make w longer in order to make that right triangle, or do you think we're going to make w shorter? Hopefully when you think about it, you'll see that we have to make w longer. If I make it about this long, then when I project v onto it, I have my right triangle. So we need to, hopefully in this equation, we're going to multiply w by a scalar, by a number that's going to make w longer. And hopefully in making it longer, we'll get that right triangle. So what we're trying to do is make w longer so that when we project v onto it, we get our right triangle. So we're going to use that equation we had where it was the dot product of the two on top divided by the magnitude of the one we're changing squared. And this is going to give us a scalar, a number. And we're assuming that number should be greater than 1 because we can see in this picture that w needs to get bigger. So we're going to take this scalar we get here, this number greater than 1, and we're going to multiply vector w by that number in order to make vector w bigger, longer. So let's start with the dot product. I have 1 times -1 plus 8 times 2 divided by, let's find the magnitude of w. So that's going to be -1 squared plus 2 squared, which is 1 plus 4 which is the square root of 5. And we're going to square that magnitude. And whatever this scalar is, I'm going to multiply that scalar by vector w. And we're hoping this scalar should be greater than 1 because it's supposed to make w bigger, at least according to our picture. So let's multiply this out. I got negative 1 plus 16 over 5. Negative 1 plus 16 is 15. Divide that by 5, and that gives me 3. And then I'm going to multiply this vector by that scalar to get negative 3, 6. And if we look at this vector that we've drawn, about negative 3, 1, 2, 3, 4, 5, 6, that's pretty close to what we had drawn to get us our right triangle. But just like we did in our drawing, we did need to make w bigger in order to make that right triangle with v. So that is what we call the orthogonal projection. Orthogonal meaning making a right angle. And you'll have a couple examples of this. Now, the good news is you don't need to memorize this equation. It is on your reference sheet. You just need to know how to use it, how to apply it. So that is it for this video. We have one more application of the dot product, and it's using work, a physics term. And we'll do that in the last video for this lesson.